Kia ora Year 12, here's day 7 holiday revision. Today we're back to 3 trig questions. So the first one that I've put in is one of the ones that we looked at, I think the week that I was away sick, so 2 weeks ago. And then the next one is an equation solving one. So this one here we can do in 2 different ways. So have a think about that. Try and do it both ways to get in some practice at each method. And then the last one should say prove that cos of x plus sine of x squared is less than or equal to 2. So pause the video and have a go at all 3 of those and see how you get on. Okay, so in this first question we've got a function which is 2 sine x minus root 12 cos of x. So I've got x here as my angle, so the x's are the same. Unfortunately this is a 2 and this is a root 12. So don't get confused into thinking that we can use these rules directly, because we can't. These ones are good when, so the sum to product rules are good when I've got so I've got a sine and a sine, and I've got 2 different angles. So that's not what I'm looking at here. But what I've got here is 2 sine x minus root 12 cos x. So we're going to let that equal r times sine x minus alpha. So we're working backwards from here into my compound angle thing. So remember, we do this using Pythagoras. So r sine x minus alpha can be expanded as follows. R sine x, whoops, always get that wrong, cos alpha, minus r cos x sine alpha. Okay, so we've expanded this to get this minus this. And now we're going to match up the 2 sine x with this, and we're going to match up the root 12 cos x with this green bit here. So we'll write each of those things out now. 2 sine x is equal to r sine x cos alpha, and root 12 cos x is equal to r cos x, and I'm running out of space, sine alpha. So we can work with those 2 equations separately. What does that give me here? Well, I've got 2 is equal to r cos alpha, and cos alpha is equal to 2 over r. On this side, I've got root 12 is equal to r sine alpha. So sine alpha is equal to root 12 over r. So the next step is to draw my little triangle. Here it is. This side is 2, and this side is root 12, and this is alpha. So what's r? Well, by Pythagoras we can say this. R squared is 2 squared plus root 12 squared. So r squared is 16 and r is equal to 4. On the next slide I'm going to draw that out a bit more, because our next step is to figure out what alpha is. So I've now got this triangle, 4, 2 and 2 root 3. So this triangle is similar to the little version of it here, 1 root 3 and 2. You can see that each of these sides is double the length of my special triangle. So what does that tell me? Well, that tells me that alpha must equal pi on 3. So now I can write the following statement. F of x is equal to 2 sine x minus root 12 cos x, and we can rewrite that as 4 sine x minus pi on 3. So that's good, but we weren't asked for that. We were asked to find the maximum and minimum value of that function and figure out the smallest positive values of x where they happen. So what does f of x look like? F of x is equal to 4 sine x minus pi on 3. So the period of that function is still 2 pi, because of my coefficient on x here is just 1. But the sine curve has been translated rightwards by pi on 3. And the amplitude is bigger now. So the maximum value is y equals 4. Now where does that happen? We're asked for the smallest positive value for that one. And it happens pi on 2 out from here. So x is equal to pi on 3 plus pi on 2, which is equal to 5 pi on 6. What about the minimum value? Well, that's going to be negative 4. So the min is y equals negative 4, and that's going to happen another pi degrees on from here. So that happens at 5 pi on 6 plus pi, which is 11 pi on 6. Now, if you like thinking in degrees, this would be, so that's 60 degrees. This point is 150 degrees. And this point here is 330 degrees. And my function would be written as x minus 60 degrees. So I didn't specify in the question. It's good to get in lots of practice with radians because most of us find those harder to work with than degrees. Okay, so that's the first question done. Now I'm going to move on to the general solutions one. So we're asked to, well, I've asked you to solve this. Cos of 5x equals 2x. Now I've just, cos of 2x. So I've just given away the first way to do this one, which is using general solutions. So when I do this, I'm going to say, well, what's the principal value that's going to give me this number over here? So alpha is equal to cos inverse of all of this. So this feels strange, but it works really well. So alpha is equal to 2x. Using my general solution for cosine, that means that this angle, 5x, is equal to all of these values. So 2n pi plus or minus alpha, which is 2x. I'm now going to split up into two cases. I'm going to have 5x equals 2n pi plus 2x, or 5x is equal to 2n pi minus 2x. So manipulating each of those, here I'm going to get 3x is equal to 2n pi, and over here I'll get 7x is equal to 2n pi, leaving me with x is equal to 2n pi over 3, and x is equal to 2n pi over 7. So n is any integer value. So that's fine, but it's not very satisfying in some ways. What we're going to do now is look at a different way to solve it, and we're going to see that we come up with exactly the same solutions. But we can do a little bit of graph drawing to satisfy our intuition. So here I've got cos of this, and I've got cos of this over here. So the other way to do this is using the sum to product rules. So we'll do that next. Right, so we start with cos of 5x equals cos of 2x. Now we turn that into a difference, so cos of 5x minus cos of 2x is equal to 0. But I know, possibly from my formula sheet, that cos of A minus cos of B is equal to half sine of half the sum times the sine of half the difference, but the difference has to be reversed. In other words, we're going to do B minus A. So how can we apply that? Well, we get cos of 5x minus 2x is equal to half sine, half the sum, 5x plus 2x over 2 times sine, half the difference reversed. So 2x minus 5x over 2. Whoops. Where's my bracket gone? There we go. So what do I have? Well, I have half sine 7x over 2 times sine negative 3x over 2. But I know that sine is an odd function, so that's just the same as negative a half times sine of 7x over 2, sine of 3x over 2, and we know that that equals 0. Now, if you're tempted to skip the next slide, I wouldn't, because I want to make sure that you've all got a good idea of how to draw these graphs and get all the solutions out from here. Okay, so we've got this into factored form now, so that's going to be our next step. We've now got negative 1/2 sine of 7x on 2 times sine of 3x on 2 equals 0. So either sine of 7x on 2 equals 0, or sine of 3x on 2 equals 0. So let's draw both of those sine curves. This is really good practice for modelling. So what's the period of this function? Well, it's 2 pi divided by 7 over 2. Right, we looked at that when we did some modelling work, and so that gives me a period of 4 pi on 7. So first draw the sine curve and then put in your numbers. That's the easiest way to go. So one full cycle is here at 4 pi over 7. Let's have a look at where this curve will be 0. Well, look, it's all of those red bits, and you can read them off, and you can see that x is equal to negative 2 pi on 7, 0, 2 pi on 7, 4 pi on 7, and so on. In other words, x is equal to 2n pi on 7, which is no surprise, but it matches up exactly with what we got from our general solutions. And we can do the same thing for this solution. The period is 2 pi over 3 over 2, right, that's that coefficient, which is 4 pi on 3. So now drawing that sine curve, what do we get? Well, one cycle is at 4 pi on 3, so it will equal 0 at all of these places here. And that leaves me with x is equal to 2n pi on 3. N is any integer. So you can see, of course, it matches what we got when we did the general solutions approach. But I think doing it this way gives you a little bit more intuition. Right, one last question, and then that's it for today. Okay, so this is the easiest of the three, and it's going to lead into a harder question tomorrow or the next day. So we're going to prove that. So prove cos x plus sine x squared is less than or equal to 2. So prove that. Okay, so on the left hand side, cos x plus sine x squared is equal to cos squared x plus 2 sine x cos x plus sine squared x. And that's the same as 1 plus sine of 2x, and that's less than or equal to 1 plus 1, since the maximum value of sine 2x is equal to 1. So we've done it. It was that easy. So cos of x plus sine x squared is less than or equal to 2. Now we could do something similar with a minus sign in there, but this video is already way too long, so I'm going to stop there for tonight. Thanks for watching. Let me know if there are any trig things that you would really like some more examples done on over the next week.